co-founder of Eddy and the GM North America for EdMaker. I'm very fortunate here to have me with here today, Victor. Victor, you want to take a moment to introduce yourself?
Yes, thanks, Terence. My name is Victor Pereira. I currently work as a lecturer at the Harvard Graduate School of Education. I am the science lead for the Teaching and Teacher Leadership Program, and I am the co-director of the Teaching and Teacher Leadership Program as well.
Thanks, Victor. Yeah, it's exciting to have Victor here today to discuss a very relevant topic for us. For those of you who are familiar with what Eddy and EdMaker does, this is something that is very close to our hearts. So let's jump right into it. Before I kick off, some of you in the audience might be wondering what emerging technologies we're going to be looking at today. In order for us to define what are emerging technologies, we're using two definitions that we adapt from New Media Consortium's Horizon reports. It refers to technologies that have not yet been widely adopted into the K-12 learning environment in the US. At the same time, number two, they're expected to have a widespread influence in the utilization and acquisition of future of work skills. So just to give you an example of what emerging technologies look like, right? For example, some of you might be familiar with Teachable Machine. It's a machine learning tool that equips learners with basic understanding of AI through a project-based approach. This is considered an emerging technology because although some classrooms and some teachers have adopted it in their lessons, widespread adoption is still not present. And at the same time, I mean, AI, which is at the foundation of Teachable Machine, is indeed expected to have a huge influence in the future of work. In the same way, Figma, another software, is an industry standard for UI, UX, and graphic designers, but it's not conventionally adopted into K-12 classrooms. And what we want to do is to contrast that with things that are not emerging technologies, things like Zoom, LMS, Kahoot. These are edtech tools, but right now they're not emerging because most teachers have successfully adopted them in their classrooms today. And I think another question that we are thinking about, another question that we spend a lot of time grappling with is, why does emerging technology require or warrant a maker approach? When, you can teach emerging technology or teach any technology as if it were a regular lesson, right? As if you were teaching a content-based subject, right? So I want to kind of put forth three paradigms here, right? For the use of emerging technology in the classroom. And the first one is teacher-centric, right? The teacher uses emerging technology within their classroom to showcase examples of how it could be used. The students don't get to touch it at all. The students don't get to play it. It's the teacher who is using emerging technology. In this case, engagement might be high, but you're not going to see a lot of active learning, and you're not going to see a lot of deep understanding of the emerging tech in question, right? Because it's the teacher who's using it. The second paradigm is when a student uses the technology, but the instructional material he's given puts forward the technology in a step-by-step format. And this is kind of popular. This is very popular these days, right? Because many times you see instructional material that teaches students how to use technology by saying, step 1, open Figma. Step 2, open this file. And you see a very structured, heavily scaffolded recipe of sorts, right? Where students are told to stick to a formula and they don't have a lot of room to explore. And in this case, of course, engagement's there, active learning's there, but the student might not understand technology, might not understand the emerging tech in a very deep way. What he's understanding is essentially how to follow instructions, right? How to follow a recipe. Now, the third paradigm is a maker-led approach to the use of emerging technology. Instead of a recipe, we give a scaffold, but we also give ample space for the students to explore and to tinker with the product, right? We give them the room to make mistakes. We give them some open-ended questions to challenge themselves. And it's this framework, it's this paradigm that leads to a deep understanding of technology. So I'm just going to put this up here, all right? And hopefully it'll become clearer as the webinar goes along, how we think design and simulation technologies can achieve the third paradigm that I'm talking about here, the iterative approach. All right, so the agenda for today, we're going to talk about what are design and simulation tools. Why should I use them in my classroom? We're going to do a contrast between online and hands-on design tools that a lot of teachers who have makerspaces might be familiar with. And then we're going to talk about how we can integrate some of these tools into their classroom. Then I'll hand over the time to Victor, and Victor is going to explain and shed a bit more light on an example of a design and simulation lesson package that we have on our online product, Eddy. All right, so this is a simple, and when I say simple, I'm not exaggerating. There are many design and simulation tools out there, so trying to condense it into a simple graph is often challenging. But if I'm to take a stab at it, what I'm doing here is on the x-axis, you see different categories of design and simulation tools. You have tools that are catered for 2D design. You have tools that are catered for 3D design, for animation, as well as others, right? And then on the y-axis, what you see is introductory level, at the lowest level, introductory tools, and at the highest level, industry-grade tools, right? Things that working professionals, practitioners would be using in their day-to-day lives. So let's just take an example of the 2D design space, right? Many of you might have used Canva. I use Canva all the time to generate collateral, to generate kind of marketing material. But increasingly, we are seeing teachers use Canva in really creative and innovative ways to introduce their students to how to create rich text, for example, for English, right? So these introductory tools can be used in the classroom. Then from there on, of course, you have the whole Adobe suite of software from Photoshop to InDesign, things that industry professionals use. And then somewhere in the middle, you have this new product of Adobe called Adobe Express, right? Which is more functional than Canva. You have much more, functionalities and options, but it's a little bit easier to use than Illustrator or InDesign, right? And of course, these categories are not hard and fast, right? Canva does have some animation capabilities. And at the same time, it's also kind of industry grade, right? I use it for my work all the time. But this is an attempt to kind of lay the landscape out, right? For anyone watching this webinar who might be new to design and simulation. And to show you guys that, well, there are different categories. And sometimes for students, we don't need to introduce the industry grade stuff, right? We can look at what's at the introductory level to kind of, introduce them, right? Introduce them to a piece of software. But what are design and simulation tools? So I'm just going to outline a few common features of all these tools. These are not exhaustive. These are based on our experience working with many of these tools. The first feature is that it's used to create designs, right? And I think this is obvious, right? It's used to visualize structures and systems, either in 2D, in 3D, in what I like to call 4D, right? Which is animation over time, a moving image over time. And there are other specialized software, specialized tools that are used to visualize structures and systems too. So that's one, it's used to create the designs. And the second one is it's used to simulate behavior. And this is interesting because it's essentially asking the question, if I change a condition, what's going to be the impact on the final design, right? If I change different variables, how is my design going to change, right? And this is tremendously important when we're looking at sciences, as Victor will share later. Now, the third feature is about data analysis. What is the outcome of my simulation? All right, I'm going to take a step back and we were talking about Canva before, right? Canva has a very interesting feature called Magic Edit, right? And what Magic Edit does is it lets you change an item in an image to another image, right? In a very naturalistic way. You might not even realize that the image has been changed at all, right? So if I use this Magic Edit feature to simulate the behavior, all right, I want to change my teacup in my initial photo over here to a coffee cup, right? If you look at the third kind of column over here. What is the outcome of my simulation? The outcome of my simulation is that, you know, tea in a saucer is changed into a latte, right? Into a latte, and that's the outcome, right? I'm looking at the two before and after, and I'm analyzing the outcomes of the situation. Then we look at the fourth column, right? Solving problems, right? Design and simulation tools are used to solve problems, and it essentially asks the question, how can I refine my design to better address the problem? Let's say you are a designer for Starbucks, right? And you want to change your initial image from a teacup to a latte in a saucer, right? And then your manager tells you that, oh, actually, I don't want a latte. I want a pumpkin spice latte, right? Very seasonal. I want a pumpkin spice latte. You got to ask yourself then, how can I solve this problem, right? How can I refine my design to better address this problem, right? And what I'll do essentially is to go back to Magic Edit again, and I'll key in the words, right? I'll actually type in, in order to design my eventual collateral using AI. I'll say, okay, I want to have a pumpkin spice latte down here. And then the design will be returned and it'll help to solve some of our challenges, right? I want to caveat here that, not all design tools have simulation features and vice versa, right? This is pretty much from a practitioner's perspective, what we see are common features of design and simulation tools, right? Now, I think some of us might be wondering, why are we even learning about design and simulation skills? What's the point of learning of them? I mentioned that emerging technologies in general, they're going to be faced with a huge demand from the workforce in the future. And what does that mean? This means that employers are going to be asking your students as they graduate. They're going to be interviewing graduates and they're going to ask them, do you know design and simulation skills? Do you know Canva? Do you know how to use design and simulation tools? And students and graduates with a good grasp of these tools are going to be more successful in the workplace than those who don't. Let me give a few examples, right, about how design and simulation is used in the workforce. Some of these examples might surprise you. Aeronautics engineering, I think this is one of the more popular examples. And here, design and simulation is used to simulate the process of airflow into a turbine. All right, and this is used in anything from jet engines, all the way to designing, say my friend who does this is not aeronautical engineering related, but my friend who works in Dyson uses similar software to simulate the airflow into the vacuum cleaner. So we want to simulate the flow of air in this case to make sure the engine doesn't overheat. And this requires complex software in order to design a product that meets the specifications. A less common example, patient flow in hospitals on the right over here. So healthcare systems around the world face a common problem, which is how to make sure that throughput is as efficient as possible. And when I mean throughput, I mean how efficiently can we get patients in and out of the hospital so that other patients who need attention from medical staff can get it. Design and simulations software is used to simulate how fast patients move from different stations, from your nursing station to your triage station, so on and so forth, to estimate how long a patient needs to stay at a hospital and how quickly he or she can be discharged. All right. So there's software that's actually catered specifically for this. A couple of other quick examples in architecture, right? A lot of building modeling software is used to design different levels, either from a 2D top-down bird's eye view, top-down kind of bird's eye view simulation, or from different levels over here. And it's still widely used in the architectural field. The last example that I'm going to give is a really interesting one. A little bit dated, but I think this will stick in everyone's memory. COVID-19 wasn't so long ago, right? And one of the big things about COVID-19 is that we had to socially distance, and a lot of essential services a lot of people needed to stay away from the office. The creators of this software actually license it for free to use in all offices. And what it does is it estimates social distancing measures and how occupancy in your office might be simulated. It estimates or it gives managers and management a good idea of how close people would be next to each other according to different levels of occupancy in over the course of a day, right? So in the lower picture over here, right, where you see a lot of blue, the blue zones indicate that there's not much human contact, right? The green zones indicate where there's more human contact. And when you go up to 75% occupancy of the office, you see a lot of green zones. This means that people are interacting. And some red zones, which are danger zones, right? Which means that a lot of people might be congregating there often. And you might want to watch out for those areas as spots where COVID might easily spread due to close contact of people, right? And this is powerful design and simulation software because it illustrates a few things, right? It illustrates how software can be repurposed for novel scenarios. In this case, they repurpose this simulation software to look at COVID-19 distancing requirements, social distancing requirements. And it also illustrates how relevant design and simulation software is, right? Addressing like what was at that time something with a huge need. But the third thing that took me by surprise was that I never knew that design and simulation software had this use case until reading up about it. So what I guess the whole takeaway is that, you know, design simulation software is going to be pretty important in different domains, not just the domains that we think of as highly relevant. I think when we talk about this kind of software, a lot of us talk about architecture, engineering, but in domains like medicine, facilities management, it's going to be really important and it's going to have many use cases in the future. And preparing students with design simulation software, preparing students to work around and work with this software is going to be tremendously useful for them in the future. Let's talk a bit about hands-on versus online design and simulation, because I know within our audience here, we might have a few teachers who've done many of this hands-on design and simulation, right? What's essentially hands-on making, constructing something with your hands. And I want to contrast that with online design simulation, kind of like fleshing out the similarities and differences in a particular use case. So I've been with AppMaker for a bit more than a year. And one of my first projects actually, was to conduct a lesson for students where we taught them about how solar energy works. Now, this is a group of upper elementary school students. So we bought these little solar kits, right? So some of you might be familiar with them. These kits that they assemble, you can put a solar panel at the top, and the energy from the solar panel is used to generate like a little fan, like a turbine, right? So this is one way that we use to illustrate the potential of solar energy to generate energy, right? That's one thing we did, right? Now, a year later, and in this June, just this June, in fact, I had the opportunity to design another lesson piece, right? And this is the same question, the same big question of how to help students understand the use of solar energy, just with online tools, right? So what we did was we used a software called Tinkercad. All right, it allows for online simulation of currents and circuits, right, to illustrate how solar energy might be able to power a certain number of light bulbs for a certain amount of time, right? And this was especially useful because we could adjust different variables. We could vary the number of solar panels, vary the number of light bulbs in a way that we couldn't with a hands-on kit, right? Additionally, what we could also use was an online calculator called PV Watts, right? Where students could enter different variables such as DC systems, different solar panel modules, you know, the angle of tilt of your solar panel, and from there derive the average wattage or average energy. I guess derive an estimate of how much energy a solar panel could obtain over the course of a day. So these are very two different examples of illustrating the same foundational point of how to make solar energy more accessible to students. And what I realized is that, you know, with hands-on tinkering with some of this design and simulation tools, it's a more tangible experience, right? Students are actually connecting solar panels to currents. They are practicing their fine motor skills. They are being engineers in a sense, right? They're actually doing what real life engineers might do in terms of connecting circuits, in terms of making sure things work, right? And collaboration is more intuitive in the sense that when we had 2 or 3 students work on one kit, we saw that intuitively, they were able to split up the work, they were able to work collaboratively. It was a bit more intuitive. In contrast, when we did the other activity where we got them to go on Tinkercad and play around in PV Watts, right? We saw a few things, right? There was digital precision, right? The simulation tool was able to tell them if they change different variables, what are different impacts in the output? In this case, it's power generation, right? What are some tangible impacts in the output? It was very precise. Iterations were also very quick because, like I mentioned, you could add another solar panel, you could add more light bulbs, and so it led for a faster iteration cycle, and students could understand more easily the kind of the sort of changes that will result when you make different variables different, when you change different variables. So both hands-on and online design simulation skills have different benefits, right? And I would say that the best overall approach would combine elements of both. So just to give you a quick example, we have done, we have developed, we have got students develop a battery charger, right? Develop a solar panel battery charger for their handphones, for their cell phones. And for this, it blends hands-on and online design simulation because we get them to design the case of their battery pack on Tinkercad, and then they print it using a 3D printer, and the assemblage of the solar panel and the wiring is done in a hands-on way. So there are different ways to get around this, right? By blending both hands-on as well as online mediums. So I'm going back to this graph again, right? Our taxonomy of design and simulation tools. As we go up from introductory to industry grade, we need more scaffolding, right? Teachers, we will need to provide templates or pre-built files in order to showcase the students how well to use it. If you're not going to provide templates and don't provide pre-built files, your students are going to be really confused, especially when it comes to software like Unity, which is totally what industry uses, but can be a bit intimidating to the new user. Right. So what we realize is it's totally essential to provide some of these templates or pre-built files for students to add on and for students to tinker around, right? We want them to explore, we want them to tinker, but we have to give them a template and a foundation to build off. So now I'm going to showcase one of the examples of how we use design simulation in our lessons. I'm going to give an example from our online tool called Eddy. If you haven't signed up for it yet, you should do so. It's a free online tool with resources that use emerging technology in maker-centric ways. So if you go to eddyforteachers.com, which I'm going to give everyone the link at the end of our webinar, I'm just going to type in here, right? Predators Food Quest. And what I'll see is a whole range of lesson plans, right? I can also navigate to resources and go to digital making, right? And do the same here, right? So this lesson is 120 minutes long. It's for science, intended for 4th grade and 5th grade. And the other great thing that we have is we connect it to certain standards, and both from ISTE as well as next generation science standards. We also give the full resources in the form of the teaching slides, the worksheets, as well as an exit ticket. And the entire lesson package is over here. So I'm just going to go through the lesson real quick and then hand over the time to Victor to unpack it even more. All right, for this lesson, learners are going to use a special food chain simulator tool, which is like a game that will help them understand how animals and plants depend on each other for food. Then they will play around with different creatures to see how they interact and learn about the important connections that keep our environment balanced. In terms of the lesson objectives, I want students to explore the food chain simulator and solve challenges related to it. And I also want them to draw out a food chain for the ocean ecosystem, right? So after playing with the simulator, I want them to draw a similar food chain, but for a different ecosystem. Let's take a look at what the main activity looks like. So firstly, the main activity introduces producers and consumers. This is kind of prior knowledge that they need to know before they go into playing around with the simulator. Introduce what carnivores, herbivores, and omnivores are. Again, this is background knowledge that they need to know. After introducing the food chain, we introduce them to the food chain simulator, right? And for this food chain simulator, I'm going to pull it out right here. So this is a really cool design and simulation tool that's used to simulate different food ecosystems. So I could pull, say, omnivore eats plant A, right? I could chart out some of these relationships here, right? And I could chart out a food web, right? According to what's on the left. And then on the right, once I click run, you'll be able to see how the food ecosystem, how the ecosystem interacts with each other over time. So I'm just gonna click run. And you can see at the bottom over here, it charts out the number of each animal or number of each living organism over time. And this is pretty rich because students can change different variables. Instead of omnivore eats plant B, I can also set it to eat plant A. I can change different variables and then run it again to see how things might change, right? So this is a quick and easy, really quick and fast introduction to a design and simulation tool that we use for one of our lesson packages. And of course, this is just a tool, right? You could craft any number of lesson packages we have with it. But what we have over here in Predator's Food Quest is an entire lesson that's kind of built up with the intent and purpose of exploiting all the affordances and all the use of this design and simulation software that I'm showcasing right now. So now I'm going to hand over the time to Victor, who's going to spend a bit of time to unpack this lesson and share with us a little bit about what he thinks are the classroom users of this lesson. Victor, over to you.
Great. Thank you very much, Terence. So to start off, one piece that I'm going to share is, really thinking about Eddy as a platform is a huge resource, a library of high quality instructional materials. And so, the next few minutes that we're going to dig deeper into this particular resource is going to be from the perspective of, how do I use this in my classroom, from an educator's perspective. Or even, thinking about if it is even a one-off resource, right? I want to implement or incorporate these ideas into, my learning spaces. So we'll talk a little bit about that and what it looks like, and a couple, introduce a few frameworks that might be helpful for thinking about how it's aligned with our current work. Oops, delayed. So the first piece, introducing a framework. One piece that working with a lot of new teachers in a teacher preparation program, there's been a shift from really thinking about lesson or activity design and more a shift towards curriculum literacy. And what that means is really thinking about how do we use high quality instructional materials. And part of that curriculum literacy is, embeds this intellectual preparation protocol. So if I find and I identify a resource, an artifact, a lesson plan artifact that I want to use in my classroom, how do I prepare it so that I can use it in that space? So the first step is really understanding the big concept. I think I would even say a step 0 before this, which Terence already outlined, is really understanding how the artifacts, how the resources are presented. You can see, how to search the platform, as well as, how it's outlined in the information that's shared. So then, spend the time understanding the big concept or big idea at play at the lesson. Be able to summarize that and name what the learning objective is. Do the core tasks. So just quickly, Terence was demonstrating, how to use some of the tools in this design and simulation based lesson. And I can't encourage it enough. Do your own assignments as an educator. One, it prepares you to anticipate some of the challenges that students might have. and it helps you problem solve when it actually happens in the classroom. I guess even a third piece would be thinking about what is the potential? How can this tool be used, beyond how it's presented in a particular activity? And so the third part, which I mentioned, anticipating misconceptions, or even some procedural challenges. Where might students get hung up, either if they're working individually or in small groups? What are they currently able to do? What do they know and are able to do? And what type of supports might you have to embed in the learning resource as it exists? Make adjustments as needed. This might be swapping out learning activities or models that are more relevant to a student's life. In this particular case, there's one general ecosystem that's represented. You might want to shift that depending on student interests or even geographical location. And then the last piece is thinking about how we go about and use this resource and refine it, and even get to the point of rehearsing. I think it's really important to walk through your script and think about what I need to say to my students, how I'm checking for understanding, what are the where do I need to be at any moment in time. So from a teacher's perspective, one thing that's really important here for me would be alignment. To use these resources, really thinking about how does this fit into my current practice, my current curriculum. So Terence mentioned that each of their resources are tagged with the next generation science standards. So thinking about this fitting into a 5th grade science classroom, you can see here that this is a life science standard. And it reads, develop a model to describe the movement of matter among plants, animals, decomposers, and the environment. So these standards here, one, it starts to identify the relationship between content, skills, and in this particular case, not only skills in science, the science and engineering practices, which we'll talk about in just a moment, but also technology or emerging technologies that we want to incorporate. Again, Terence listed a very simplified graph of all of the options out there. I think a teacher's responsibility is identifying which tool is appropriate. Where are students currently at, and how does the technology, the tool, help us understand the science? So, using this example, I'm redefining, design and simulation as aligned with developing and using models. One of the next generation science standards, science and engineering practices. So when we think about the design, this part of the science and engineering practice is what we're considering developing models. How are students developing this model, in this particular case, food chains or food webs? For the simulation part, how are they using models to learn science, to communicate science? Again, going back to the simulation tool, what data is being generated so students can understand or describe a phenomenon. So these are the two examples. Now, taken directly from the criteria or the expectations at the middle school grade level for developing and using models, this particular activity, learning activity, aligns with two of the expectations. One will be developing and or revising a model to show the relationships among variables, in this case, omnivores, herbivores, carnivores, at different trophic levels. And later on, an adjustment that I wanted to suggest and think about is how you can enhance learning, elevate learning, is develop or use a model to predict or describe a phenomenon. So thinking about incorporating socio-scientific issues, which we'll get into in just a little bit. So the other framework that I want to introduce here actually references Terence's point about a paradigm shift. So what you see here is this idea of the three main parts of these learning resources: open activity, the main activity, and the closing activity. And here are examples from this particular lesson. One way that this aligns and fits into my practice is thinking about inquiry-based learning. So the opening activity aligns very directly with what we use as the engage phase of this learning progression. The engage, how do we hook students? How do we diagnose what they currently know, what they're interested in, what connections they're making to previous learning? The main activity, again, just in terms of language and alignment, thinking about breaking into 3 parts. The explore. In this particular case, exploring how to play and learn using the main activity. The explain, how are students given new tools, vocabulary, and language so that they can apply to a different context or a different challenge. And then the closing piece, the elaborate piece, giving them an opportunity to simulate using the models that they've developed to try to answer a question, solve a problem. And then the closing aligns nicely with, as an exit ticket routine to evaluate student learning. How have they, what evidence do we have that students are learning, and how have they met the learning objectives for a particular day? So thinking about the opening activity, I think this is grade level appropriate. I think it's engaging for students to think about reading this riddle and trying to identify which organism in an ecosystem it is describing. Now, after students have had an opportunity to do this for multiple organisms, I think the value here, thinking about from a teacher perspective, is debriefing this learning activity, debriefing this phrase. And so what's important here is highlight what have students learned. When they appropriately identify which organism this is describing, thinking about, asking this question generally, where is this organism getting its energy from? And the reason why that debrief is particularly important, or that check for understanding, helps students, reflect on that first phase of learning, is because we're going to give it language later on. We're going to ask students to then identify, well, using the definition of an herbivore, where does that organism get its energy from? So get a chance to introduce students to this basic concept of energy flow in an ecosystem by solving these riddles. Then we have the exciting part of the explore. This is where, going back to this idea of an inquiry model and Terence's point about a paradigm shift, this is where a teacher has to be really intentional in terms of balancing how much support versus at what level of inquiry. So this is where an instructional decision comes up for me in terms of how much of this is play to learn, how much of this is directed play, how much of this is a straight out tutorial showing them how to do that. And to me, I think it's a balance. And part of the balance is also sequence. So for this particular phase, it's show some basic components, make sure that there's some procedural check for understanding, make sure they understand, literally how to add organisms and make the connections. Terence made it look so simple. 5th graders might take a little bit longer to play and figure that out, but they'll figure it out. Give them a directed challenge, and then allow that learning activity to be how they understand how the simulation works, understanding the technology. And in some ways, they're understanding how to build this model using the simulation. And in other ways, they're understanding what the simulation will be able to do, export a level of data, which Terence showed us in terms of organism population numbers. Oops. Great. The explain connects directly to the explore in this case. After they've had a chance to explore, and I think, taking a half a step back, the explore being an opportunity for them to build a chain, a food chain, right? A smaller component of a complex food web. Coming back, the explain allows an opportunity to debrief. What did students learn by playing? What question, even better, instead of, have them share what they learned, have them share what questions they have. Where did they, hit some roadblocks in terms of using this particular tool? What were they trying to demonstrate and, didn't figure out how to? Another thing is How did they meet this particular challenge? What do their food chains look like relative to each other? How are they slightly different? And is that okay, right? Having an opportunity to share different models, meeting the same task and challenge. And so this is then the opportunity for them to understand also the data that's being generated, and talking about that, analyzing data, so another science and engineering practice, as well as thinking about the relationship between a food chain and a food web. A food web being a collection of food chains. This is where I really get excited, because this is the opportunity here where, as you're building this technology literacy, you're getting comfortable with this tool. You're realizing what the opportunities are for this tool in terms of learning, or actually conducting a level of an investigation, right, as it simulates data and relationships. I think you want to use the simulation to answer, the following question: what would happen if X? Now, this X, this is where it's teacher, have at it, have a blast coming up with crazy scenarios. An organism goes extinct. One of your herbivores goes extinct. The lesson plan specifically talks about a brush fire. So you would imagine what would happen to the population of certain organisms. You introduce an invasive species. Any of these, socio-scientific related issues that students can start to think of, oh, wow, I can answer a question by manipulating and revising my model, and then running it to see what the data looks like. So this is where students get excited, because allow them to make a prediction. What do you think will happen? How would you answer this question? Now, use the tool so that you can actually run data. And then the last piece, the lesson plan in Eddy has a very valuable exit ticket. And this is self-reflection, self-assessment. Hearing from students' language, what did they learn? In a lot of ways, put the objective back in front of them and saying, like, what are examples of what you learned about, this particular topic and how we did it? Something that I would think about to continue extending the learning based on that elaborate phase is asking them to draw their food webs to answer that extension question. What would happen if X? And then asking them to use vocabulary. Again, as teachers, we're really trying to think about how it fits, how it aligns, but also we're double dipping a lot of times, right? There's layers of a lesson plan. So we can't forget that, learning emerging technology is not isolated or siloed. It's in service of learning science and meeting the content and skills or practice objectives. So this is the last piece in terms of, in summary of, how I would use this, how I generally think about taking high quality instructional materials and asking educators to implement them in their classes. One, there's dozens upon dozens of instructional decisions. A couple of things that come to my mind here is thinking about when is it appropriate for students to be working individually versus collaboratively. Even just on the simulation, is it 3 folks? One person has their hand on the mouse and other folks are directing them to say, go ahead, let's add a mouse or a squirrel at this point. And how much do we want them, when is it appropriate? And then debriefing the learning activity. Every time you're transitioning, giving them the next task to do, what is the bridge that really connects those pieces? Thinking about checking for understanding, highlighting the learning. Scaffolds, like we talked about, is balancing this level of inquiry, how much you're giving them versus how much you're asking them to figure out. And then the last piece is, just the excitement with an activity like this, when, it's this dynamic model through design and simulation. How much are you giving them a common model, like building a model together? Maybe part of the explain could be like, all right, you had a chance to play. Now let's come back and let's build a food web together to start before you go make one on your own. Then obviously the opportunity for individual models. So I think Terence probably expects me to be at my time right now. I think I did a good job, Terence.
Yeah, you're earlier than what we planned, but that
Okay,
gives us more time for Q&A.
wonderful.
Uh, Hearing your sharing was great. I want to capitalize on a couple of things before I forget about it. You mentioned about this balance between tutorial, directed challenge, and free play, and that's something that we think a lot about. We think about quite a lot, right? When we are looking at how students and teachers interact with software and tools. Here at EdMaker and here at Eddy, we mostly use tools that are very open-ended, right? We use emerging technology tools that have the affordance for students to create artifacts. And something that we're always thinking about is when to hold tight, when to let loose, what's the right amount of support and scaffolds that you want to give for a student to make them feel comfortable in using a tool, but not so much that they feel restricted, right? So you want to give them freedom, but also give them the support. So what are you mentioned a little bit about that, but I'd just like to hear your thoughts about how teachers can manage that tension and manage that scaffolding, I guess.
Great. So Terence, I think that's where I really appreciate that question. One, I'm going to go back to just the opportunity to look at different levels of inquiry, right? That's how I'm going to respond to your question, not necessarily using your paradigm shift. And it goes, levels of inquiry, this is from the National Science Teachers Association. It goes from confirmatory all the way to open inquiry. You can think about it in terms of how much do you just like jump into it and figure it out versus how much are you directed to learn, piece by piece, that scaffolding example. And so when I think about this in working with teachers, anytime we're talking about the science and engineering practices, or we're talking about academic skills or competencies or dispositions, we start to think about it not as like, what is the only goal for today? You're not going to be able to master or meet proficiency today. It's more of, think about Massachusetts. What's the 180-day plan? If students are with you for 180 days, what is your goal today, tomorrow, and a month from now when it comes to design and simulation, or any one of these categories, whether it's content skills or tech literacy? So that's how we're thinking about it. And so then it's important to think about a true assessment strategy so that you're making informed decisions, right? You're identifying the appropriate zone of proximal development any point in time to make these decisions. So diagnostic, what are students capable of doing already? Give them a task and see how far they can get. Formative, how are you regularly checking in to see what students can do, but more importantly, giving them opportunities to either self-assess or giving them feedback. And then, the summative at any point in time is like, well, what do you expect them to be able to do independently? We're working towards, to your point, we're working towards essentially academic independence, open inquiry, right? Where they can go ahead and realize, oh, I have this project. Let me go ahead and use Tinkercad as a tool to present my project rather than a teacher saying everyone has to use Tinkercad or.
Yep. Thanks so much, Victor. I think that was that was a great way to put it, right? I think speaking to the power of assessment and really, I think your answer really places the teacher at the center of the classroom, right? Which is why when folks are saying, AI is going to take over the teaching profession, I'm not so sure, right? Because I think that the teacher has to make, as you said, dozens and dozens of decisions about how tightly to support students, right? And make decisions about uh, how to make the next instructional move based on feedback that you're getting from the students. That all of that is reinforcing the idea of the importance of the teacher in the room making those decisions, whether it's for the month, for the week, or for that 180 days you're saying. I had another question about these design and simulation tools in general. So not specifically for this lesson that we're talking about, but in your experience, right? I mean, you've been in the classroom quite a while. You're working with dozens of science educators across the year. What do you think is the value add of design and simulation tools like this in the science classroom versus traditional ways of, simulation and modeling? Because the Massachusetts, the NGSS and the state standards all say that we have to do modeling and as part of the requirements. They don't say you have to do modeling using technology. So what do you think that the technology and the software tool helps to value add to the whole process?
So when I think about technology, I get excited. I get excited and interested in the shiny object. But as an educator, I am very, very, very cautious of using things or implementing them just because they're the next shiny object, right? They have to have a purpose, a tool. But I'm referencing a conversation that we had, prior to this webinar, and just really thinking about, like, once you're developing this general technology literacy, understanding how things are designed, put together, what they're capable of doing, then you're making those decisions for yourself, right? So I think generally, you mentioned at the very beginning of the webinar, is just this college and career readiness. What does the next generation of active and informed citizenship look like? And we're going to have to be able to use these tools. And in science specifically, there are a lot of different phenomena that we just can't see, whether it's scale, time
Right.
scale, or size scale. So this is extremely valuable. And students, when they're responsible for, when that information, excuse me, that responsibility is put in their hands, they really have to understand the general system that they're representing, in the components, in the relationship, whether they're designing it from the ones and O's up, or they're using a simulation that exists and they're in charge of manipulating it to get an answer to the question they have.
Gotcha. So really just seeing not just from the college and career readiness standpoint, but also when you look at deep understanding of the topic, how the variables are interconnected. In this case, as in other elements of other topics in science as well, it helps them to see these connections and these relationships in greater detail. Mhm.
Yeah, absolutely.
Cool. I just wanted to, we have some audience members here. So I just like to throw the Q&A session open. We do have a few more minutes. So if there's any question you'd like to ask Victor or myself, please feel free to ask away in the comment section. We'll wait for a couple of minutes. And as we're waiting for questions to come in, I'm going to share with everyone how they can access this lesson once again, as well as access the other lessons on Eddy. So as you can see, eddyforteachers.com is an online portal that's developed by EdMaker. It's developed to address two problems, right? The first one is teacher focus, right? Teachers, there's a lot of technology tools out there. Teachers can sometimes be overwhelmed by it. And a lot of the most powerful and most transformative tools can sometimes also be the most challenging to use in a classroom. So we want to simplify that process for the teacher. And the second challenge is with students, right? We talk about future ready skills, we talk about college and career readiness. The current education system that students go through might not be the best to prepare them for what the future needs. So what we have are resources, right, that all use different emerging technologies and are all constructed according to maker-centric principles. So think of you can call it online making, you can call it online maker spaces, whatever you want. The idea is that these are problem-based PBL lessons designed with designs using emerging technologies that also bring in a maker-centric approach to it, where students are creating with technology, not just consuming it. So you can search for different lessons. You can even filter by subject, grade, domain, as well as standards. And you can see for design and simulation alone, we have around 22 lessons, all featuring different types of design and simulation software, from Canva to Adobe Express, Jamboard, anything from elementary school all the way to high school, although most of our lessons are focused on elementary and middle school. All right, so this is a resource that the teachers amongst you can tap into for using your classroom. And if you do use it in your classroom, give us a shout out. I'd love to hear how you guys are using it to enhance your current teaching and learning. All right. I don't think there's any questions so far, but if you do have any other questions for Victor or myself, please feel free to reach out on LinkedIn or through email. You know where to find us. We'd be happy to hear what you think about this sharing, as well as any ideas you have for webinars in the future. We will be having another webinar in the future. It's 2 weeks from now, and I believe it's it's on augmented reality, virtual reality, so mixed reality tools, and that's going to be a pretty exciting session. So look out for that. If there's nothing else, I think we've come to the end of this webinar. And Victor, do you have any last words?
No, Terence. Yes, Terence. Thank you for having me on. This is really exciting because in a lot of ways, I think the theme was for me in terms of my participation here is how to elevate and enhance learning. And these tools that are showcased in the lesson plan resources are absolutely one way that students can be engaged. They learn real world skills and in service of learning, specific disciplines.
Thanks, Victor. That's a lovely way to wrap up our session here today. And thanks for everyone who joined us today, and we'll see you at our next webinar. Thank you. Okay, I thought that was pretty good. I stopped the stream. So